Welcome everyone to the video. Here we'll be discussing question 8, 9 and 10 for activity 2.1. So let's get started. So question number 8 and 9 are based on this common data which is provided over here. So A is a real 3 cross 3 matrix where C1, C2 and C3 denotes the columns of the matrix A. Now we are also given few set of matrices where we have matrices A1, A2, A3 and A4. And the question 8 asks that which of the matrices have the same determinant as that of A. So we know this property if we do any column operation, such as let's say in column I, we are adding some multiple of column J, so that should not affect the value of the determinant. So we'll be using the same property over here. We'll start with the matrix A and we will try to do such column operations on A to obtain matrices A1, A2, A3 and A4, and let's check with what all matrices we can obtain from here. So if we start with A as C1, C2 and C3, and if we perform this operation where in column 2 we are adding 5 times of column 3. So what will happen? We will obtain this matrix C1, C2 plus 5 times of C3 and then C3. So this is basically our matrix A1. So we used this property on A to obtain A1. Hence we can conclude that both A and A1 have same determinant. So option number 1 is correct. Now moving on to the option 2. So if we apply this operation over here, where we are saying in C1 we are adding C2 and C3. So we will get C1 plus C2 plus C3, and then C2 and C3 will remain unchanged. So here we obtained A2 by using the same column operation. So that means that the determinant of A2 is equal to determinant of A as well. So option number 2 is correct as well. Now moving on to the option 3, here we have no way to make this C3 as 0. So that means A3 we cannot obtain by using this property. And what about A4? So let's do this thing, and that in the matrix A, we will first add column 2 to column 1 and then column 3 to column 2. So we will get this matrix where we have C1 plus C2 and C2 plus C3, but C3 is as it is. So now if we try to add the first column to C3 now, the first column now has become C1 plus C2. So if you do this operation again, where you are adding C1 to C3, so it will eventually become C1 plus C2 plus C3, because now this entire thing C1 plus C2 is your column 1. So you cannot obtain A4 by using this property as well. So this was the solution of your question number 8, and we can find the continuation in the question 9, where it says the determinant of A3 cannot be determined from the given information. So first let's see what A3 is. So in A3 we have our column 1 C1, and then we have our second column as C2 plus 5 C3. So C2 plus 5 C3, and then we have a 0 column. So we know since there exists a 0 column here in the matrix A3, the determinant of A3 is going to be 0. So that means we can determine the value of determinant of A3 from the given information. Thus, option 1 is incorrect, and the option 2 that says determinant of A3 is equal to 0 is correct. Now, moving on to the third option that talks about the determinant of A4. First, let's write what A4 is. So, A4 is given by C1 plus C2, and then C2 plus C3, and then C3 plus C1. So before we delve into this question, there is one property that you need to keep in your mind, and I'm writing the property over here. The property is, let's suppose I have to find the determinant of this matrix where I have A, B, C plus P, D, E, F plus Q, and G, H, I plus R. So the determinant can be split into the sum of two determinants given by A, B, C, D, E, F, and G, H, I. plus AB. So the first two columns will remain unchanged, whereas we are splitting from the third column itself. So we had C over here, we'll put P over here, and then we have DEQ, and then there is this GHR. So this is the property that we have for the determinant. So here we'll be using the same property for our A4 as well. So let's get started. Here I can write my determinant of A4 as determinant of C1 plus C2, then C2 plus C3, and then C3 plus C1. So this could be split into two parts where I have C1 plus C2 here, C2 plus C3 here, and I'm just picking C3 from here. And the second part is C1 plus C2, C2 plus C3, and here I just have C1 with it. Okay, so now we can apply some of the column operations over here. So here what I'm going to do is I will subtract uh, column 3 from column 2. That means I'm going to do column 2 minus of column 3. What this will give me? This will give me uh, C1 plus C2 and then just C2 and then just C3. And later here I can apply maybe column 1 minus column 2, and that would give me C1, C2, C3. This is basically determinant of A. Okay, I'll do the same thing to this particular determinant as well. So what we will do is we will say column 1 minus column 3. So that will give us a C2, C2 plus C3, and then C1 again. And now we will do one more operation, which is column 2 minus of column 1, which will result in C2, C3, and C1. So this is just determinant of A, whereas we can fix this as well. So here what we will do is we will apply column exchange. So what we are going to do is first we will exchange column 1 with column 3. So when we do this, what we will get? We will get a matrix like this where we have C1 over here, C3 over here, and C2 over here. And then we will do column uh, 2 gets exchanged with column 3. So that would result in C1, C2, and C3. So we know this fact that if we apply column exchange for the first time, the value of the determinant gets multiplied with -1. But since we are applying the operation for 2 times, the value of the determinant will remain unchanged and we will get C1, C2, C3. C2, C3, which is again determinant of A. So it is determinant of A plus determinant of A. That means 2 times of determinant of A. So here we have A4 as 2 times of determinant of A. So this option is correct. But this option is incorrect because we have already seen that determinant of A1 is equal to determinant of A2 is equal to determinant of A. This we have seen in the question number 8, where the value of determinant of A1 and determinant of A2 was equal to that of A. Okay. Finally, let's move on to the question number 10. That is the last question for this activity. It says that if the diagonal entries of a 3 cross 3 lower triangular matrix is 1, 2, and 3, then find the sum, the roots of the equation. So I'm taking my A as some arbitrary matrix, which is lower triangular matrix. So lower triangular matrix means this. These 3 entries are 0. Now it says the diagonal elements are 1, 2, and 3. So I'm taking diagonal elements are 1, 2, and 3. And then I'll put some arbitrary values over here. So let's take PQR. So it is a lower triangular matrix having diagonal entries as 1, 2, 3. So now it is talking about the sum of the roots of the equation A minus xi. So what will be A minus xi? So A minus xi would be this A 1 PQ 02R 003 minus of x times of 1 0 0 0 1 0 and 0 0 1. So that would become x is 0 0 0 x is 0 and 0 0 x by multiplying x with each and every element of this particular matrix. So here we will obtain this matrix which is 1 minus x 0 0 p 2 minus x 0 q r and 3 minus x. So this is the matrix A minus xi. Now we want to find the determinant of A minus xi. So we can observe one thing about A minus xi, that A minus xi is also a lower triangular matrix. Also a lower triangular matrix. And we have seen this property of triangular matrix, that the determinant of a triangular matrix is just the product of the diagonal elements. So here we'll just take the product of the diagonal elements to find the value of determinant, which is equal to 1 minus x, 2 minus x, and 3 minus x. And the question asks us to solve this equation where we are equating this thing with 0. So if we equate this thing with 0, we obtain the value of x as 1, 2, and 3. So these are the three possible values of x. So it says uh, find the sum of roots of the equation. So these three are the roots of the equation, and we just have to find the sum of the roots of the equation, that is sigma xi. That means first we'll add all these values, and whatever value we'll get as the sum is going to be our answer. So 6 is the answer in this case. So that was all about this activity 2.1. We'll see you in the next video. Till then, have a nice day. Bye.